Hey everybody, how's everything going today? So I'm going to get started with another MacBook board repair for you all. Hopefully you all enjoy. Today we're going to be getting started on the show with an A1502 that has no power. We're going to open this thing up and we're going to figure out what's wrong with it. If we can figure out what's wrong with it, I'll explain our thought process and what was actually wrong with it on camera so that you can have a better idea yourself how to do these types of repairs. Let's get started. Open this thing up. Looks like it's been somebody used packing tape to hold it in, which is really annoying. Very, very annoying. So first thing that I like to do with any of these machines is see how much power it's taking using the power supply. The power supply is going to tell me how many amps it's using, and that's going to give me an idea of what's actually wrong with the machine. We're going to turn on the multimeter and power supply software here. Award-winning, world-acclaimed multimeter software from Mr. Paul Daniels. All right, we're taking 20 milliamps. We have a green light. The 20 milliamps is usually a way to signal that the PM Sleep S4L is missing, which is great. Now, it looks like we got corrosion in the area that's responsible for creating PP-Bus G3 Hot. So the next thing I want to do is see if PP-Bus G3 Hot is actually being created. Let's take a look and see. Now, PP-Bus G3 Hot on this board, I do believe is going to be located on this white fuse down here. And for those of you following along at home that are not used to me working on this board, who don't really understand why it is I'm checking for that power rail, well, that's a great question that you've got as to why I'm checking for that power rail. Let's go over it really quickly before I move on to checking that power line. So I'm going to open up the schematic and board view for an 820-4924 board so that you can all see and follow along with me. Now, what I have over here is board view software that's opening the board in the wrong orientation, but besides that, we have U7100 is the chip that it's got some junk around it, and this is battery charger. It's going to create my PP-Bus G3 Hot right over there. See that? PP-Bus. So I'm checking on F7140 where it creates that. Let's see what we get. 1.1 volts. And look at that. Well, now if you take a look at the schematic, how do you know what that's supposed to be? Well, one of the ways that I used to do this is I would just check it on a known good board. That was my foolproof way of figuring out the way things are supposed to be. But if you are kind of, you want a way to tell that's a little bit more foolproof, that's completely understandable. What you can do is you can check on the schematic itself. Now, they used to have this list of power rails right in the beginning to make it nice and easy on folks, but now they put the most important part of the schematic on page 68 because Apple. PP-Bus G3 Hot. It says 8.6 volts. Now, this is another part where the schematic is not going to be very helpful because this machine is actually supposed to have 12.6 volts, not 8.6 volts. One of the ways that you can tell this is by checking the voltage in a known good battery. This is 8.6. That's actually for a MacBook Air. So this Apple schematic gets its own voltage wrong. It doesn't know what it wants. This is supposed to be 12.6. So the schematic here is actually wrong. And this is where having a known good board can actually be more helpful than checking certain things in the schematic because sometimes the schematic itself can be wrong. So let's take a look on the board and see if we can just fix this issue with a little bit of hot air and flux. Before I even get into doing the hot air and flux thing, I'd like to see what that specific resistor that's messed up is actually for. Charger DCN and charger A gate. All right, so that resistor over there is supposed to be 332 kiloohms. And I'm pretty sure it is. I would wager a guess that the issue here is not going to have anything to do with the resistor being bad and everything to do with the ISL 6259 being bad. See, 331 kiloohms, so that's It's supposed to be 332 kiloohms. That's not really going to be what bothers me here. The issue is going to be a bad ISL 6259. I'm going to guess that it's the chip that's wrong. So let's give that a replacement and see if it fixes our problem. I'm going to put a little bit of flux over there. Not too much and not too little. So we're going to replace our ISL 6259 and have a proper board. %, Randy. 100%. I did that before I bought that freaking switch. That TP-Link is only about a year old. Doesn't the iron work so much better when you turn it on? Alright. Yeah, Spectrum was horrible. Can I get the audio file for robust? Congrats for the new store. Hopefully your stress level will be back to normal soon. Thank you. Yeah, it's been very stressful recently. It's been stressful on everybody, really. Everybody's had a lot to do. It's going to be even more stressful on Paul since he just went on vacation to Vegas and he's going to be staying at a hotel where they have lots of gambling shit right downstairs. That is nice and crooked. From one ThinkPad enthusiast to another, keep up the great work. Hope to hear some Fisher for future streams. Maybe. Thank you. This is my donor over here. We're going to let this dry by utilizing rapid cool technology. It's rapid cool technology. $18 milliamps. No difference. No change. Okay, now we got to do a little bit of investigating. Still 1 volt on PP-Bus G3 hot. Next up. Do we have a short to grounds on PP-Bus G3 hot? No short to ground, 6 million ohms. Fuse is good. Okay. Current sense. Current sense good here, current sense good there. Let's see, did I forget how to solder? Maybe I forgot how to solder. That's always possible. Never know. Alright, so let's see. Is the charger even turning on? So we have Q7180 over here. This is the inrush transistor. And one thing I'm kind of curious to see is, do we have voltage over here at the beginning? So let's just check in voltage mode. Let's check on... Okay, so like right over here. What do we get? So do we have 20 volts coming into the machine? 18, I suppose. $18 comes in. Very good. All right, so now we have this thing over here. I want to see what's coming out of the transistor. Oh, for fuck's sake. Oh, that's pin 2. I'm hitting ground like a dumbass. Okay, let's measure here. Yeah, so 1 volt comes out of the transistor. Now the question is the transistor being asked to open? Because, you know, I can't really blame this transistor for not opening if it's not being asked to. So what you have going on here is this is the 18 volts from the charger, and there's a resistor between the 18 volts from the charger that goes to the source of the transistor, and 18 volts of the charger going to the gate of the transistor, which means that this P channel is never going to open. This is only going to open if the voltage on the gate is less than the voltage on the source. However, you have this other resistor, R7186, that goes between the gate and ground, but before it gets to ground, it goes through U7100. So U7100 can control whether this transistor opens by allowing or not allowing this to go to ground. This becomes a voltage divider if the bottom of R7186 here is allowed to go to ground, and then you'll have less voltage in the gate than the source and it'll open. So let's take a look at R7186 and see what's present on pin 2. R7186 pin 2 is going to be there. And you got 16 volts. So the U7000 is not telling this transistor to open. That's why it's stuck. Let's see. $17 here. 16 there. Alright, let's check some other stuff going on here. So why isn't U7100 doing its job? U7100 is not sending that to ground. Let's see, is R7105 good? Or did you blow? R7105 is going to supply power on charger DC in. It's supposed to be 20 ohms. And your 20 ohms. That's not it. Well, this is quite the troll. Trace from R7186 to the ISL may be corroded. You know what? That's actually a good idea. Let's check for that. So from here to here, right? Yo. Okay, it's not that. It's the trace. It's between the resistor and the fucking probe point. Look at that. Son of a... I didn't see that. Okay, this is... I gotta raise the light or something. Okay, let's raise the exposure all the way. Yo, YouTube comment fucking fix the board. Why doesn't this happen more often? Okay, this is max exposure right here, and even at max exposure, I can't see it. Look, check this out. So, this resistor over here, R7186, that's going to be the path between the gate and the ISL 6259, which is going to bring it to ground. So for this to work as a voltage divider, for the voltage in the gate to be lower than the voltage on the source, R7186 has to go between the gate and ground, or else R7185 is just going to take the 16 volts from your charger and send it straight to the gate. R7186 is what's going to take that voltage from the gate, send some of it to ground so that you get down to about 9 volts or so. And the connection between the probe point going to R7186 and the ISL is good. But the probe point to R7186 was blown. Wow. Look at this. So, see, this is the probe point. Let's see if I can get a better image there for you folks. Look at this. That's good. 0 ohms. But the probe point to the resistor, it's gone. Damn. No, really. That's damn near invisible. Like, how the... Come on. Yeah, but look, when you scrape away, you can see that there's no copper between the probe point and there. See? It's gone. Let's see, maybe if I scrape a little more. Wow, this has never happened before. This is... No, look, the copper is there. Oh, wait, no, I take it back. There is copper here. What is it, like intermittently conducting copper? I mean, what the hell is this? What are we talking about here? I don't think this microscope light actually emits enough light for me to give you zoom at this angle. I think I have to get a more powerful microscope light. I had to replace mine recently because it died, and this microscope light's really not doing it justice. You can't see well when it's all the way zoomed in like this. I gotta get myself a better microscope light. I'm sorry, folks. For the people watching, this is, I think, like the $30 or $40 M-scope light, but they make some $200 microscope light that's way nicer. I was being a cheapskate, so my apologies, folks, because you can't really get a good... You can't really see what I'm seeing here zoomed in. Here, I'll zoom out a little bit for you. This is good enough. Remind me to get myself a better light, because this thing's not doing it justice. But yeah, look, that trace is barely broken. Look at that. You have to scrape... The thing is, it looks like it's intact, but it's not. It looks like it's intact. It's quite tricky. Yeah, I need way more light. It's enough for me, but it's not enough for the camera, even at max exposure. I'm going to get a stronger light for this. Placebo effect, Bob in Delaware. Alright, so I'm going to have this wire going straight to the chip to the probe point, and then from the probe point to the resistor. Let's secure it towards a new light. Thank you, Ed. Ed, I haven't seen you in a while. I hope you're doing well. Sorry at all for cheaping out on the light here. I wonder if I could just send more voltage to this light. I wonder how long it'll last before the diodes die. That would make a fun experiment, because I have another power supply here. I have a spare power supply here. Would be kind of fun. Send 30 volts to Lewis's microscope light. Alright. I can make a fun video. Okay. Well, there's still some flux there. We just do that. There we go. That was off my game. I eventually what I would have done is I would have wiped the entire area. I just would have windshield wiped the whole area and scraped it, but that would have been very inefficient. So I would have most likely replaced that transistor. Nothing would have changed. At that point, I would have just windshield wiped all of this, which would have gotten me my solution, but it would have been way down the line. But this makes a lot more sense. Okay, so it looks like we're taking 60 milliamps now, which is an improvement, but that's still not turning on. Now this is just being a troll. Whoa. Okay, must have just had a loose connection. There we go. 590 milliamps. Where's your pee-pee bus at? 12.6, baby. 12.6 volts. 12.6 volts. So the charger is going to go through this transistor. However, it can only go through this transistor if the voltage on the gate is lower than the source. So you have this setup here that allows the ISL6259 chip over here to control whether this opens. The voltage in the gate has to be lower than the source. You have a resistor that takes the voltage from the source, the 18 volts, and puts it straight on the gate. Then you have another resistor that goes between the gate and the ISL6259. So if the ISL6259 doesn't do anything, then nothing will happen. But if the ISL6259 shorts pin 2 of R7186 through to ground, then this will work as a voltage divider. It's very similar to the backlight circuit I went over in a recent video, and this will open. And the connection between pin 2 and the U7100 was bad, and I couldn't notice it. See, one of the things I was talking about here was like when you get the cheap shit, what happens? This is the cheap-ass, like, shitty $20 on Amazon microscope LED ring light. You notice when I zoomed in, I couldn't really see very well. Whereas my old microscope light, I could really turn it up and dial in the detail, because the more that you zoom in, the less light goes through. And I needed to be able to zoom in to see this. So I didn't think to check that trace, because visually it looked totally fine. Even at 20x it looked totally fine, and I missed it. So I'm going to get myself a better microscope ring light so that this doesn't happen again. I learned my lesson. Or I may just try sending more voltage through this one just for fun. I kind of wonder what happens when I send 30 or 40 or... Hell, I got my bike charger over there. Let's send 58.8 volts to my ring light and see what happens. So that's it for today. I hope you learned something, and I'll see you all in the next video.